Today we are doing lesson 15, length measurements. Let's solve some problems about distances and lengths. So you're going to look at page 68 in your workbooks. It is called Which One Doesn't Belong? You're going to look at A, B, C, and D and decide which one doesn't belong and write a couple notes about why you picked what you picked. Let's share. Which one doesn't belong? Quick.
I think C and D because both of them are in whatever those things are called.
Parentheses?
And they're and one of them is a fraction and the other one is multiplication. But B is multiplication, but it's times 1, not times 18. So, yes.
Okay, maybe. Right, Kara?
I think none of them belong.
Oh, none of them? Why?
Because none of them are like the same and belong with each other.
So none of them are the same, so maybe none of them belong. Okay. All right, let's hear one more. All right, Cade?
I think they all don't belong because the first one is the only one using feet.
Okay, so this one has feet.
Then the next one, it's using yards. The next one, it has a multiplication problem, and then the next one has fractions.
Yeah.
Okay, so all four quantities, put your hands down, all four quantities measure lengths. What do you notice about the lengths? Aaron?
They all connect because inches equals 12 inches equals feet, and feet equal yards. Yards equals miles, which is not on there.
Okay.
But they all intersect from each other. They go up and down. The measurements are related.
All right. If we convert the quantities that are equivalent to 1 yard into feet, what would they all be? Aaron?
3 feet.
3 feet, because 3 feet equals
A yard.
a yard. So this one says 3 feet. If I convert it to yards, okay, so that would be 1 yard or 3 feet. Do you guys know the rule about parentheses?
Yeah.
Always do parentheses first. 3 times 1 is 3. So this equals 3 yards. How many feet are in 3 yards? Coral. 9 feet. 3 times 3, right? Here, 2 times 18, we do the parentheses first. What's 2 times 18?
36.
36. 36 inches equals what?
1 foot. 1 yard. 1 yard.
1 yard. Or 3 feet. Okay, if I add a third plus a third plus a third, what do I get? 1 yard, right? All right. Launch. Have you guys ever played Frisbee or another game that involves tossing an object?
Yes.
Okay. What do you notice? What do you wonder? Look at this table up here. What do you notice? What do you wonder? Raise your hands. Let's share. Vivian.
Why is it even a table? Why does it have different students' names and distances?
All right, that's a really good point. Are we collecting this data for some reason? Aubriella?
How come Elena and Tyler don't have their distances?
That's a really good question. Elena and Tyler have nothing written down. Uh-oh. Jerica.
yards and feet instead of like all feet or all yards.
Why do they keep switching measurements, right? Or units? Okay, Madeline?
I wonder why there's fractions for some, but just feet for other ones, but there's not fractions for other ones.
Did you guys notice the fractions in there?
Yeah.
Okay, last one.
I wonder why Andre
I think.
has yards and feet.
So it says, let's find out who the top frisbee throwers are in this group of friends. So we've got a group of friends and they're throwing frisbees. 6 students were throwing frisbees on field day. Here is some information about each person's first throw. Elena's frisbee went 3 times as far as Claire's did. Andre's frisbee went 4 times as far as Tyler's did. Complete your table with Elena and Tyler's distances. Explain or show your reasoning. There we go. We don't have Elena or Tyler's distances because we have to figure them out, right? So they gave us some clues. Do not start yet. Number 2, who are the top throwers for that round? Find out by listing the students and their distances in feet and in order from longest to shortest. If you throw your frisbee, you're going to be the top thrower if yours goes the longest, right? Okay. And when we synthesize, we will go over the tables. All right. You're going to work with your math partner about 10 minutes. Okay. So, let's take a look at Elena and Tyler. So if I look at Elena, here's my clue. Her frisbee went 3 times as far as Claire. Well, if I look at Claire, Claire's frisbee went 21 1/3 feet, right? So if I'm saying Elena's is 3 times as far, guys, then I'm doing 21 1/3 times 3, right? How do I solve that? Help me out. How do I solve that? Chase,
Use
sit on your bottom, please.
split 21 1/3 into 1/3 times 3 and 21 times 3.
So I could take the fraction and multiply it separately and take my whole number and multiply it, right? Guys, what is 1/3 times 3? If I have 1/3 3 times, what do I have, Jerica? So it equals 1 whole. What is 21 times 3? Coral.
63.
That's going to be 63. What is 63 plus 1, everybody?
64.
So Elena is going to be 64 feet. Are you with me so far?
Yes.
Okay. Now I'm going to erase this so I have room to do my work. Let's look at Tyler. Andre's frisbee, he has 22 yards, 2 feet. Went 4 times as far as Tyler's did. Keston.
You convert the 22 yards into feet, and then once you've done that, you do what 65 times feet is 22 yards per feet divided by 4.
Do you guys notice that that Andre has yards and feet? we need to put it all as one unit. So if we switch it to feet, okay, 22 yards. How do I change that to feet? How do I change it to feet, Jerica?
Times it by 3.
So we'd have to do 22 times 3 because there are 3 feet in 1 yard. What is 22 times 3? Brooks. Okay. Kaylin? That's going to be 66 feet, right? But I need to add the 2 feet, right? So everybody, what is 66 feet plus 2 feet?
68 feet.
So I know Andre threw it 68 feet. If Andre's frisbee went 4 times as far as Tyler's did, what am I going to do to solve this? Aaron.
You're going to divide 68 and 4, and when you divide and when you multiply, we figured out we were Cameron and I were like, oh, is it 16 no? Is it 18 no? Or 17?
So you did like some guess and check.
Yeah, so we multiplied like 16 times 4 and 18 times 4 and 17 times 1 and got 68 plus 17 times 4.
You could certainly do that. Another way you could break apart that 68, and you could say, oh, okay, 4 times, I don't know, 10. That gives me 40, right? Okay, well, it's not quite 68, so maybe I could do 4 times 5. What's 4 times 5? 20. Oh, 40 plus 20 is 60. I have 8 more to make 68, right? Oh, isn't 4 times 2 8? Okay, so then I can look at these numbers. What is 10 plus 5 plus 2?
17.
There's our answer. Questions? Okay. If you know how to do long division, could you do long division?
Yeah.
Okay. What is 28 divided by 4? Who knows their math facts?
What was the question?
7. Right? Okay. All right, you guys. Then the second part, you just had to put them in order from longest to shortest. But we're going to run out of time, so I'm more worried about this part than part 2. All right. That was our synthesis. We're going to look at activity 2. While on an outing, a group of friends had a stone stacking contest to see who could build the tallest stone tower. Sounds like something Bradley would do. Do you guys ever do things like this, like stack stuff? Okay. Yeah, his latest thing is probably a Lego. He has the jumbo Lego, so a Lego tower. Write a list of mathematical questions that could be asked about this situation. What do these questions have in common? How are they different? Is that... Oh. All right, let's just together. What are some questions you could ask? What are some questions? Keston. Okay. Coral.
Why do they do this competition and if they do it in the past and what their numbers are in the past?
Okay. Aaron?
Where did they do this competition?
Okay. Gage?
the point?
Okay, mathematical questions. We want questions with number answers. Kara.
I forgot what I was going to say.
One more. Cade.
What's the height of the tower?
Thank you. You get a magic ticket. My goodness, you guys. Come on, what are we talking about? Length, right? Jerica, did you think of one?
How many towers?
Like how many towers did they make? Okay, you can have a ticket too. Because that is a mathematical question. All right, put your hands down. We're moving on. Okay, mathematical questions have number answers. All right, and yeah, we're moving on. Okay, so, we have clues. Do you see our clues? Yes. Andre's stone tower is 3 times as tall as Diego's, but Diego didn't build the shortest tower. The tallest tower is 4 feet and 2 inches tall and belongs to Tyler. One person built a tower that is 39 inches tall. Tyler's tower is 5 times as tall as the shortest tower. Guess what? You got to solve that puzzle. How tall is each person's stone tower? And then question number 2, Elena came along and built a tower 5 times as tall as Diego's tower. Is Elena's tower more than 6 feet? All right. You're going to work with your math partner. We'll come back in about 10 minutes. So, let's quickly go over this one. Who had the shortest tower? Madeline. Claire, how tall was it?
10 inches.
Very good. Then, who had the tallest? Who had the tallest? Bella. Tyler. And how tall was it?
15 inches.
Who had 39 inches? Charlie. Andre. So how tall did Diego's have to be? Jace.
13 inches.
So then that would make sense, right?
Yeah.
Okay. Elena came along and built a tower 5 times as tall as Diego's. Is her tower more than 6 feet? So tell me, how tall is her tower? And then if it's more than 6 feet. Okay, Madeline. Okay, Jace?
Yes.
Yes. How tall is her tower?
65 inches.
Okay, so to get that, did you do 5 times 13?
Yep.
And you got 65 inches?
Mm-hmm.
Okay. Gage.
I think no, because because I drew 6 boxes and the 6 feet, and then 13 times 5 equals 65, and then the 6 boxes of 12 is 72, not 65.
I love how you drew a diagram. So what Gage figured out is 6 times 12 is 72. So 6 feet equals 72 inches. Well, Elena's tower is 65 inches. 65 inches is less than 6 feet, right? So, no. Hers would have to be less. Does that make sense? Okay. All right. It is time for your cool down. Guys, keep in mind, I'm going to give you one hint. I think you already know it, but 12 inches is 1 foot.